Hi students. So far we learned about Arduino, and we also tested blinking LED by using blink code, and we also tested conversion of analog signal which is coming from outside to a digital signal. And this is the time that we have to shift to a digital reading from an external device. Okay, let's get started. The ports in Arduino. One is digital ports and the other is analog port. We've already tested the LEDs on and off, assigning either high or low values to the specific digital ports in blink code. Arduino can also receive some information from the outside through this digital port. For that, we prepared a digital device that can send digital signals to Arduino. This is the board called ADS1115. These two boards actually exactly the same, and it has the same order of input port name here, exactly the same order, so we can use these two things without any difference. This is still ADS1115 and this is also ADS1115, but different manufacturer, but exactly the same function. We will use this to test the digital communication of Arduino. It measures the voltage value coming in from the outside and converts it into a digital signal. It's actually an AD converter, but it will communicate with the Arduino in digital way. Now we are going to use a very specific skill. Actually, it's not a specific trick, but it's a practice that will be used very often in Arduino coding. This method can be used to connect most of the external devices to Arduino. External devices such as ADS1115 have their own way of communicating with Arduino. So sometimes it's very difficult for normal users like you to connect each and every one of these methods and to do the program from the scratch. But fortunately, the people who make and sell these devices are ready to provide a way for us to use this device very easily. They try to provide as many as possible and as easy as possible ways. That way, they can sell more of their products. One of them is to provide libraries and example code. With this driver, ADS1115 is also very easy to connect to your Arduino. As a conclusion, we will try to carry out the following 3 steps. First, find out the exact name of the device you have. Second, find your library and download it. Thirdly, find the download. When the download is complete, you will find the example file and run it. After these 3 steps, you are almost done activating the device with your Arduino. So I call these 3 steps "Don't ask 3 steps." It means to proceed with these 3 steps without just asking or arguing. If your device is working very well after you exercise the 3-step process, you can go back to the code and figure out what each line of code means. This makes the code much easier to understand. Once you've seen the code work, when you look back the code, it's easy to imagine what the codes are really trying to do. Sounds good, right? So let's do the 3 steps. Okay, step 1. What's the name of the device? Yeah, that's right. It's ADS1115. Now that the name of the device has been verified, we are moving to step 2. Search the library and download it. So we will download the drivers that makes ADS1115 available in Arduino. Downloading library is also very simple. You will use the include library menu here from here in the sketch menu of your Arduino IDE, include library. And you can also select this manage library menu to open the library manager like this, and then you can type the name of your device in this search bar. ADS, only ADS will show you the libraries available. For our case, among these choices, Adafruit ADS1115 will be the right choice, and it should be acceptable. If you select this one, you could see somewhere around here the installation button. Since I have installed this library already, so I don't see that installation button, but for these cases, for just like this, you can see that installation button here. So you will find this installation button, and then you can click it. You can install the library automatically by clicking this installation button. So this is the second step. So here's third step. Since the installation of library is completed, the example code must be found and executed. The example code can be found in the example menu from file menu here. Here is the example menu, and you can find the example for your device. If you go straight down in the example list here, you can find Adafruit ADS1115 at this point. And this contains the example code for ADS1115 also. So I'm going to choose one of these selections, and I will select this single-handed. This will open an example code like this. After fixing this one, you can run this program. Since we are using ADS1115, so we have to enable this line and disable this line, because this is for ADS1015. Okay, then it's done. Now you can run this program. You can click the upload button here and to compile and upload it to your Arduino board. So I will click it. Then it will compile it. Once the compiling is finished, then it will upload the whole file onto your Arduino board, and the uploading is completed. So if you do this, it's all done already. If this code is compiled and uploaded without errors, because there is no errors for my case, open the CDO monitor button here and see what value is actually reading. There are 4 values that's coming in from ADS1115, but only -1 is shown. That's because the ADS1115 board has not been connected to your Arduino board yet. Now let's connect the board. Here is Arduino Nano, and here is the ADS1115. Even though it looks a little bit different from yours, but the order of this pin is exactly the same, so we can use this component, and you can do that connection without any trouble. And you also have this potentiometer, in other words, rotating variable register. So we can use this one to change the input analog value to here. So let's make a connection. First of all, we need to supply voltage to ADS1115 for it to work. So these two pins are used for that power supply. VDD is for +5 and GND is for GND. So I will connect that. Let's just connect this VDD to 5-volt pin of Arduino here. And I will change this to red color. So you can use the red wire to connect these two pins. And you can connect this GND pin to here on GND pin of Arduino. So yeah, let's change this to color black, since GND is usually used for with black color. And then the power supply to this ADS1115 is accomplished. And we also have to connect these two pins to Arduino, because this ADS board uses I2C communication method to communicate with other device. So we can connect this SLC to A5, because just follow this, because I will explain this later. So anyway, I can change this to blue color. And you have also another pin that we have to connect to Arduino Nano. That's SDA, and you can connect this SDA pin to A5. Okay, then I can change this to green color, so you can distinguish all these wires. Okay, so just connect this VDD to 5-volt, GND to GND, and then SLC for I2C communication. You have to connect this to A5. In this case, A5 will be used as a digital communication instead of analog communication. And SDA can be connected to A4. This is also a digital communication port in this case, instead of analog communication. Okay, then everything is connected, and then we will have to provide the varying potential, varying voltage to this ADS1115. Since we have this potentiometer, so we can use this to do that. So I can connect this port, this leg, to this 5-volt signal, because yeah, that could be possibly done by this way. And okay, let's make it more tidy. And then the rightmost pin, the third pin, should be connected to ground like this. Ground for black, and the varying potential, changing potential, will be coming out from this middle leg. So we have to connect this middle leg, one of these analog input port, A0, A1, A2, A3. These are the analog input port for ADS1115. So we will select this A0 for this case. So I will connect this line to here. I will change this to white color. White color here. Yep, here. And then I will move this wire a little bit away from the other wires for you to see more clearly. So everything is connected. I will arrange a little bit, rearrange these wires for you to see more clearly. Okay, so here I can move this ground wire, and yeah, these are the communication wires. So you can rearrange these wires in this way. Okay. Then you can see then you can distinguish all the connections more clearly. So this is what you could see after you really connect all the things together. As you can see here, the VDD line here is connected to 5 volt of Arduino Nano, and the black line here is for ground, and yellow for my case is for SLC to A5 of Arduino Nano, and SDA to A4 of Arduino Nano. And the potentiometer also connected like this, that this leftmost leg, the first leg here, is to be connected to 5 volt signal from Arduino Nano, and black line, the rightmost leg, is connected to GND, while the middle leg, which is giving changing potential, should be connected to A0. That is the analog input port of this ADS1115. This is the connection. So the connection is completed, and when you open the serial monitor again, then you can see that something normal is coming in. The value of A in 0 will change because the analog signal is connected to A0. So if you turn your potentiometer to increase the voltage, then as you can see, the A in 0 value is increasing. And if you turn the other way around, then you can decrease the input value. Okay, this much for today. And next time, we are going to study what these lines of code mean. Good luck, folks.